Test now. Find out if I hear me. Can you hear me? Hello. Okay. So this is the test. Don't submit anything to me. Okay. I'm only going to use this so that you can, if you know that you cannot and more. Okay. Then you can always send your challenges to me if there's anything you don't understand. So this is test one. Please, there's going to be a test by everybody that will teach you. I'm only just using this one to encourage you to study very well. Okay, so that is question one. Look at that. 2A. I will also use it to lecture you from some of the things I've taught you. Can you answer these questions? If you can't answer them, go and look for the textbook and be reading. Listen to the lectures. I think we've recorded all the lectures. You can see them and work on them and then try to understand. 2A plus 2B, he said the experimental rate law, but I'm saying experimental rate law, question one. I'm giving you just 3 seconds. The experimental rate law of the reaction above is that what is the overall order of the reaction? That's what I'm looking for. The order is not the same thing. I've said experimental rate law. So the order is not 2. The order of this one is not 1. But I have determined the experimental rate law. Look at it here. What is the order? K is raised to 3 over 2. B is raised to 1 over 2. What is the overall order? Can you add 3 over 2 plus 1 over 2? If you do, you will find one of the answers there. And that is what I have asked, question one. If you don't understand it, that means you are far away from the beginning. Okay? Then that's all. Question two. The rate law for the reaction. Look at the rate law for the reaction. Has been established. So I have done this experimentally. So the rate law has been established. This one is 2 seconds. Has been established to be this. What are the units of K if the concentration are expressed in mole per dm cube? So this is it's easier for you to do. And I said rate, that is mole per dm cube per time. Just take seconds. And that is equal. Look at that, K. This one is raised to 1 over 2. The other one is raised to power 1. Okay? So what are the units? So put mole, you know the meaning of this, but it's raised to half. Can you manipulate that experimentally? Oh, sorry, when you're doing it, can you manipulate that? If you put mole per dm cube here, you put mole per dm cube is the last one. And this one's raised to 1 over 2. The second one is raised to 1. Can you remove 1 mole per dm cube, 1 mole per dm cube here? You still have half here. And then how you go to manipulate it? Where you're finding the unit for this. One of them is the correct answer. You see how I have used all the units, the way I have manipulated them. If you don't understand how to work them out, you can't get the answer. One of them is the right answer. Which one will you pick? This is just unit, and I've taught you. What if I don't put 1 over 2 there? If I say rate is equal to K raised to power N. Work out the units, work out this unit. Can you do it? So these are the similar things that can be given to you. Okay? Now let's go. What about this? This one is 2 seconds. The decomposition of dinitrogen pentoxide is described by the reaction. Look at the reaction. I taught you this one. I even gave you the mechanism of this one. If the rate of appearance of nitrogen 4 oxide is 0.80 mole per dm cube per second. What is the rate of appearance of oxygen? Look at oxygen here. What is the rate? Look at the mole ratio. Look at the way I balance it. Which one? Will oxygen appear faster in quantity? Will it be up to 0.8? Look at the answers below. Can you look and pick the answer? just in a second. Even when you pick the right answer, make sure you follow the unit. If the answer is 0.2, it's not 0.2. I'm not saying it's 0.2. And they are saying mole per dm cube per second. Another, you can see another 0.2. Look at that. Per mole dm cube second. They are just using that one to, do you really know it? If you don't know it, immediately you see 0.2, you will rush to 0.2 and then begin to pick the wrong. So you must also check the units. If you do, you will able, then you will able to get, a lot of marks from similar questions. Okay, now I give you another one. Look at that. What is the activation energy? This is another question. For a reaction, which is triple, which triples its reaction rate as it changes the temperature from 35 to 50. I told you, this 35 add 273 to it. This 55 add 273 to it. But it said, it is log of K2 over K1. I didn't give you K1, I didn't give you K2. But I said it is triple. That means it's going to be 3K1 over K1. So you cancel that K, and everything on your left will be left with log 3, and that will be equal, so you can calculate the activation energy. Once you do that, you will get one of the answers there. Then let's go. Look at this. The rate of formation of E, very quickly, we have a few minutes left. The rate of formation of E is found experimentally to be dependent of the concentration of B. That means independent, it does not depend on B. Forget about B. And second order, this is theory, and second order with respect to A. If it is second order with respect to A, it means the order with respect to A is 2. If the initial rate of formation, you are giving the initial rate of formation to be this, calculate the specific rate constant. And that is rate, look at that. Rate is equal to K into A. They said it is 2, the power is 2, is there. You raise it to power 2. They're giving you this one. Put this one here where you have rate. Put, what is the concentration? Okay, when the initial concentration is 0.4, put 0.4 here. And then you can calculate K. One of the answers will be the right one. Okay, look at this. We have just a minute and a half left. At 40 degrees centigrade, look at that, 40 degrees centigrade. The reaction B into C is 0 order respect to B, 0 order respect to B. If the initial concentration of B is 0.05 mole per dm cube, and the specific rate constant, so you are giving rate, look at that, rate is equal to K into B, okay? And they said, if the initial at 40 degrees centigrade is 0 order, so raise it to power 0. Anything raised to power 0 is what? 1. So everything is equal to K. Can you, the specific rate constant, calculate the half-life of the reaction? So you can, well, immediately you know K, and then you can always go and, you know the initial concentration. Calculate the half-life. You know the relationship for 0 order. I taught you the half-life for 0 order reaction. Go and look for the half-life from the note I gave you earlier. Once you know K, and you know the initial concentration, and then you can calculate the half-life. So that is the last question for that. I've been able to go through the 6 units that I prepared for you, and I've covered this aspect, okay? And I appeal to you to go through all these lectures. I think they're available. You can go to either YouTube, or we've recorded all of them. I have even listened to some of them. And I encourage you to always have a discussion group, meet with some of your friends, some of your colleagues. You can have your own Zoom and be having a discussion group, and so that you can understand. If you don't understand, ask. That's why you're here. And you still have about, 5 more lecturers to interact with you. And I wish you success. I wish you good luck in UI. And I pray that we understand anything that is not very clear to you as time goes on. So have a great day, and see you some other time. How did it go? Is the phone call there? Okay, recording. Did you record this?
What is on YouTube?
Okay. Okay, you can open it now. Let's see until another lecture comes.